Faraday's law in my effort to understand why T dot is defining the EMF in a coil. T dot is the time rate of change in Faraday's equation. At the bottom have a north pole facing up. This is our core. It was made of small steel rods all cut to size and taped together. Our coil, and it's connected through to a light. Now the T dot that I was just saying, the time rate of change is the time rate of change of the flux in the path of the conductor. So for example, to light our light, if we move our conductor, and with time rate of change, the light lights as a result of the EMF being produced in the conductor. Okay, so my goal with Faraday's law is to understand exactly why and how magnetic field lines actually generate an EMF in a coil, and what structure it has to be in to actually generate an EMF. For example, here I have another set of permanent magnets. With this set of permanent magnets, if I put it in on top of the core in attraction mode, so it means we have a south pole moving down with our north pole at the bottom moving up, and if we move our conductor, the light doesn't light. So an EMF is generated, but it's not enough. There's not enough current in the coil to generate EMF to actually light the light. So the question begs, in that configuration there's not enough EMF generated in the coil to light the light. So how do we get enough EMF generated in the coil to actually light the light properly? So what we can do is, if we put our set of magnets in opposition to the magnets that are on the bottom, we have two north poles and they're sandwiched together. Now essentially the energy density in that north pole is much higher. With our coil, we do get a reasonable EMF generated in the coil when the flux is at 90 degrees. We saw that the first demonstration. We saw no EMF generated in the second demonstration, and in the third demonstration with the magnets opposing, we saw again a pretty reasonable EMF. Now what's happening here is the fields are coming out in a three-dimensional structure. They meet in the middle, but they're sandwiched together, and they're in an extremely high flux density, considering the force of the magnets sandwiched together. The coil, as it moves through this field, cuts the lines of flux that are coming out. So the requirement seems to be, for Faraday's law, that the coil, the conductor, must cut the line of flux, and essentially the lines of flux are on enclosure on themselves, but the conductor must cut the flux to actually generate an EMF. So that's Faraday's law.